And welcome to the latest installment of our Tech Tuesday webinar series. Today we're going to be taking a look at Kubernetes and specifically Azure Kubernetes Services. I'm joined today by Brett Decker. He's one of our Azure architects here at Cortex Services, and also Clint Adkins. He is our Director of Azure Solutions. So before we go ahead and get started with today's presentation, just a little bit of housekeeping. As always, if you have any questions during the course of the presentation, please do enter those into the chat. We'll get to those at the end. We'll also be sending out a recording of this webinar so that you can view it and refer back to it. We'll also send out a copy of the slide deck so that you can take a look at that as well. And then, of course, if you want to reach back out to us, you can always visit the website and we'll go ahead and reach out to you there, whether you hit the schedule a meeting or the contact us. And now that all that boring stuff's out of the way, we'll go ahead and we'll get down to the meat of it. And Clint, I'll go ahead and hand it over to you and let you kick us off.
All right, thanks, Kevin. Appreciate that very much and appreciate everybody's time today. So today what we're going to be reviewing is we're going to be going through cloud adoption framework from a super high level. It's a good place to start. We'll get into that a little deeper. We're going to talk about Azure Kubernetes Services and what it is. We're going to talk about specific scenarios to leverage Kubernetes and containers and some specific use cases that we've actually seen it implemented in. Talk a little bit about open source and how the landscape's changing from a technology perspective, and some resources and really how to get started. And as Kevin mentioned, questions and answers here at the end. So from a cloud adoption framework perspective, it's just really where you get started from Azure's point of view. So if you have not gone through a CAF engagement, whether you lead it yourself internally or have an outside group such as Cortex lead it, I definitely recommend you go through a cloud adoption framework workshop of some kind. And really ultimately what it is it's a way for you to ensure that your Azure environment's set up and configured properly for you, as well as your organization set up for success from an Azure perspective. So the key areas are looking at defining your strategy and your business use cases and motivations, and what are you expecting to get out of Azure? Are you looking at cost savings? Are you looking at agility? Are you looking at redundancy? Are you looking at being able to connect with more customers based on scalability? What are you really looking at from it? And then understanding what the business justification is and for each type of work. Then you transition into the plan phase, where you really are looking at what does your overall digital estate look like? What is your infrastructure and applications look like today, whether it be SaaS hosted, on-prem, partly in the cloud, partly in other clouds other than Azure. What is your digital estate so you can really understand what you have today, so you can put together a real cloud adoption plan for what makes sense to move to Azure. A lot of times what we'll do during that phase is we're really looking at it. If you want to get a deep dive into the digital estate, there are things called cloud economic assessments, or CEAs. There are a number of different ways to do it, but there are tools that'll go out and look at your environment and provide recommendations on what can be moved and how it could be moved to Azure. Then you move into the ready phase, where you're really designing your core Azure environment, and that includes the network, the identity, the subscriptions, security, and ensure that you really have a good foundation for your Azure environment for growth. I've seen in a couple different scenarios where customers have rolled out identity and they've used a specific different Active Directory, Azure Active Directory environment than their primary users, and there were good reasons behind it at the time. But later on, that created problems for them because they couldn't authenticate to PaaS services. And so you've really got to look at how do you design for scalability and for the future. And then building that first landing zone, or the Azure environment, building that core Azure data center, if you will. I know it's not really a data center, but the Azure subscription, how are you building that out? Are you implementing things like firewall? If you're running VMs in an Azure environment, highly recommend firewalls. It's still a data center. You still have to secure it and protect it. We're a big Palo Alto shop, but there are a lot of other good vendors out there as well that can handle it. But really implementing the core governance, including tagging standards, so that you can set up for chargebacks and showbacks within your environment. And so your business can really understand what the cost is and where your consumption is going and where your Azure consumption specifically is going. And then moving into the adopt, whether you migrate your first workload or a data center or build a new app, going through that, and then governance and management long term. It's really critical to walk through that and make sure you have a good foundation as you're getting started. So with that said, we'll jump in and have Brett go through what is Kubernetes and kind of go through some of these different scenarios.
All right, great. Thank you so much, Clint, for kicking us off there and walking through some of the prerequisites that we usually look for before we start diving into a Kubernetes conversation, including that landing zone, which is all important when we go to start standing up some of these applications and services. So AKS and containers go hand in hand. People will ask, what is a container? Well, a container is a kind of a standard unit of software that's packaged and is easily moved from one orchestrator tool to another. And AKS is the tool that we're going to go through today. You'll see here on the diagram that we have two types of infrastructures. On the left, you have containerized applications, and on the right, you have a traditional virtual machine-based infrastructure. You'll see that the hypervisor supports the virtual machines on the right in our kind of traditional VM-based methodology. On the left side, you'll see that the host operating system and Docker support the applications. Each of those applications are in a container. Most containers that we see documented in AKS are Docker containers specifically. And what's really great is that the host operating system there is supporting many of those different applications and containers. And you'll see that on the right side is almost a one-to-one mapping to virtual machine to application. So there's not quite the density capability that you would have by using containers.
Yeah, I like to look at it, and I know it's not exactly this, but I like to look at it as the next evolution of infrastructure virtualization and giving you the ability to have multiple applications running on the same operating system host in a simplified manner. And then you'll probably get into Kubernetes here in a minute and how that interacts with containers. So I'll stop there and turn it back over.
Great. So the next piece I have here is Azure Container Instances. And I wanted to highlight this because containers can be used without an orchestration tool as standalone units in Azure. They're easily deployable. You can launch them in seconds, and they're really cost effective when you're just looking to deploy a single container and you're just looking to get that stood up and running in Azure. And so this is a good place to start when learning about containers and when learning about AKS, because you'll start to get a feel for how containers work, and then you can start to consider all of the orchestration steps that make them as secure and highly available as possible. So a little more details here. You can run containers without managing servers, right? And so just the container is running in your build per cycle that the processor is running. Increase infrastructure agility with containers on demand. You can turn these containers on and off at any point. And then secure the applications with hypervisor isolation, where the containers that you're running are actually hosted completely separate hypervisors. And so you will not have to worry about breaking any compliance requirements that you might have, and you can meet all of those requirements by using the Azure Container Instances. All right, so yeah, there's no infrastructure to manage, which is really great. You can just simply point to the container that you're looking to connect a service to, whether that's local or external. Super fast to start up and turn down. And they can scale out a lot quicker than what a virtual machine could, because you're just starting the container. You're not starting that guest operating system. And so you're able to just turn the program on and connect to the service immediately. All right, so now we'll get a bit into the Azure Container Service, commonly referred to as AKS. So this is a fully managed Kubernetes orchestration service. And what that means is that you're reducing the amount of resources that you have to invest in supporting this infrastructure, because the platform is being managed by Azure and in the Azure data centers. Auto patching, auto scaling, auto updating, these are things that help reduce the operational overhead of managing this service, and they help increase the agility of being able to iterate your container development and continue to provide the best service possible without having to deal with the operational maintenance that is traditionally required. Use the full Kubernetes ecosystem. So this Azure Kubernetes utilizes all of the same containers and resources that you would expect in an on-prem or in another platform or data center. And so this is going to be a completely open source friendly implementation of containers that you can continue to leverage wherever that your organization sees fit. There's some very deep integration with the Azure DevOps and development tools, which is really great for publishing your manifest changes and updating the cluster configuration as you need to. What's also really great about those development tools is that you can orchestrate automated testing. And so when you publish a change to your Azure Kubernetes or container service, you can have these tools automatically run and create the cluster, validate that the changes are not creating any downstate containers, and then publish the results back to something like Power BI that reports on the service health, the response time, and different metrics that you may be looking for to validate that that environment came up, without having to perform those manual operations every single time that you update your system. All right, so some of the driving factors for containers: density and performance. So as we had seen on the first slide, that we had a lot of applications running on that same host operating system. And what the real benefit is that when you have containers running on a system, they may not all 100% be using the whole processor, and you can actually move the containers around between hosts as needed based on which containers are using the most performance. And so because you have that automatic load balancing, then you're able to get a very high density out of each node, which is similarly compared to a virtual machine, where instead of running one or maybe two applications on a virtual machine, we can see a dozen containers running on a single node, and as they require more resources, that they could be moved or scaled up in total volume based on those requirements at the time. Licensing costs are another huge driving factor. Reducing the amount of licenses that you have to pay, especially for those maybe guest operating systems and other licenses from vendors that are not using an open source platform. This can really reduce that overhead cost and drive long-term value for modernization. A shift to DevOps. This really supports that shift to DevOps because of a lot of the automated feature sets that are built into Kubernetes and can be pushed from DevOps to Kubernetes very easily. And the way that this integrates with the rest of the Microsoft services as well, from Power BI for reporting, we've got the Azure Log Analytics for metrics on each of the nodes and the systems. The DevOps really helps tie it all together by having a standardized deployment methodology that requires approval to change and has high transparency for what changes are made over time. Scaling out is another really important factor. As organizations continue to grow, we see that their demands may be growing as well for resources. And so some organizations with legacy environments will be met with a large cost to maybe double the size of their data center. Whereas with Azure Kubernetes Service, incremental adjustments in the size are possible at all times. And so that, and if your business cycle requires more demand at certain times of the day, days of the week, months of the year, then the scale can be adjusted very granularly to fit those requirements, and subsequently the billing will reflect the amount of time that those services were running, particularly the nodes in Kubernetes. And then faster deployment. When we're not worrying about deploying the guest operating systems, we're really able to focus on the agility that we have by deploying the containers themselves. And so this faster deployment reduces that overhead to iterate your product. And since you have less overhead to iterate your product, you can invest in other areas and continue to grow your business. All right, containers and Kubernetes momentum. So, a lot of people have just started to hear about containers, and some people have been invested in containers for a while now. And so, we've seen a lot of growth in the last few years of using containers. Gartner expects that this year, 50% of enterprises will run mission-critical containerized cloud-native applications in production.
And we're seeing that come through with our customers for sure.
Yeah, absolutely. Yep. Half of the container environment is orchestrated. So this means that the containers are being deployed automatically, and they're scaling based on demand automatically. The average size of a container deployment has grown 75% in a year, meaning that when someone is deploying a Kubernetes orchestration service, then the average size of their deployment is much larger than it was, meaning that people are starting to move real full production workloads into this service. Larger companies are leading the adoption. We see that most of the organizations, are running 1,000 or more hosts, are adopting container-based solutions. And so we really do see this as the future, and most of these companies are really appreciating the open source nature and the flexibility, scalability, and agility of the platform. All right. And so continuing on with the open source aspect here, we know that it's portable. Kubernetes can be used in public, private, hybrid, multi-cloud scenarios. And so wherever your data center requirements may be, Kubernetes is going to be capable to run in that platform. Extensible, it's very modular, pluggable, composable. It's very easy to fit into an existing infrastructure in bite-sized pieces to begin learning how to use the platform and to take advantage of those benefits as quickly as possible and start continuing to move the rest of your infrastructures to that solution. And then self-healing, the automatic scaling, automatic updating, auto restarts. It has a lot of things in place that will allow it to continue running even when maybe a node fails or there is an application level failure. What's great is that built-in tests can automatically confirm that a failure has occurred and redeploy the applications and containers that you have to new nodes in the orchestration service. And so this is really great to keep your business running online and ensure that there is minimal impact to forces maybe outside of our control. So a quick slide here I have shows what an infrastructure might look like that includes both virtual machines, and you've got the Azure container instances there. And so what's great is that you can have virtual machines and Azure container instances running, hand in hand. And so that we can implement an Azure container instance connector that can actually connect Kubernetes to the Azure container instances or other virtual machines on an existing infrastructure that you may have. And so if you need to orchestrate the scaling up and down of your containers, which in this diagram are reflected as pods, a container creates a pod that is running in each of the nodes. And so if you need to orchestrate their scaling, then you would use AKS. But if you just need the static or for a single use container, then you could leverage the Azure container instances hand in hand with Kubernetes, both using containers, but using containers in a different capacity, where one of them might be running production, and the Azure container instances may be small one-off tests, or they may be for a specific service that you require. An example is FTP service. If you only want to pay for a server when someone is connected to FTP, then you could leverage an Azure container instance that would simply bill during the connection period. And so that when the connection is disconnected, then the Azure container instance is no longer processing and is no longer charging, only the data will be charged at that time. All right, so how managed Kubernetes on Azure works. So as I'd mentioned, there's automated upgrades and patches. High reliability and availability is really brought to us because of the orchestration across different nodes. The reliability and availability is based on the fact that we can have these containers deployed on many different nodes, and that being on each node individually is not as important as the ability to deploy the container again on any other node at any time. And so being able to move the containers around really helps you when a certain application is using a lot more of the resources on that node, or if there's a node failure, that these can move around very easily. Easy, secure cluster scaling is also brought to us by the fact that the orchestration tool, based on the demands of the resources, can scale out the number of nodes and also the number of container instances that are running. The service is self-healing, as I had mentioned before, that it is going to automatically redeploy the containers if there is something that goes wrong with them. Self-testing is great because it can verify that the container is functioning as expected and automatically try to restart it or redeploy it. API server monitoring as well, and all comes at no charge here as an inclusion of the Azure Container Service.
Yeah, so all you're doing is paying for the consumption of the nodes or ACI, depending on the scenario, right, as you're using.
Yep, absolutely. And so there will be other pieces, such as the data and the network ingress and egress and things like that. But the orchestration service itself and the service it provides is at no charge.
Nice.
All right, so this slide just simply depicts how the breakdown of the operational responsibilities for managing the container service are benefited by using AKS rather than a do-it-yourself Kubernetes. So you can see there that Microsoft takes on the responsibility of a lot of the components that traditional infrastructure are used to supporting on their own. So this just plays more into the operational resource reduction.
So it's truly a PaaS service, like a platform service, ultimately, which is nice.
Okay, cool. So these are just a few of the other points that, AKS is benefited by. A few of these things we've gone through so far. CI/CD is an important part of the AKS because iterating your Kubernetes deployment is something that many organizations are benefited by to continue improving their tool. So a lot of these things we've talked through already. I did just want to throw up a quick example of some simple commands that you can look into a little bit more that show kind of how easy it is to really get started with creating a cluster, upgrading the cluster, or scaling it. All right. And as I had mentioned, CI/CD is really important here. Instead of having to go through all of the manual steps of setting up the pipeline, we can simply now create an Azure DevOps project with AKS as the target. So it really simplifies the CI/CD capabilities of your service.
Yeah, and just to throw in a quick shameless plug, if you're working on Azure DevOps and Azure specifically and struggling with pipelines, please feel free to reach out to us. We do have some Azure DevOps foundations that can help you set up those pipelines at Cortec.
Great, thank you. All right, cool. So work how you want with open source tools and APIs.
Yeah, so one of the great things about this is Microsoft really has done a good job of embracing open source tools and technologies overall. I think that's a huge story to be told here within Kubernetes services. And it enables you to either use Kubernetes, open source Linux technologies, or paid technologies. You can definitely use things like Jenkins or Terraform as part of your containerization strategy, or you can use ARM as part of that.
Mm-hmm. Yeah, it's really great that we can get all of these different vendors to kind of play nicely together and really bolster the security and storage data monitoring capabilities that we have available. There's a lot of ways to secure the Kubernetes environment. We have the role-based access control, we've got key vault, network security, and all compliant with certifications covering SOC, HIPAA, and PCI. As I mentioned, built-in auto scaling, global data center to boost performance and reach as the Kubernetes can be orchestrated across many different Azure regions. Elastically burst from AKS cluster using Azure container instances, and geo-replicated container registry so that those images or containers are available from many different regions. Some of the top scenarios for using Kubernetes on Azure are the cost savings from lift and shifting their containers, microservice agility, machine learning performance, and IoT portability. Getting into the lift and shift containers a little bit, you'll see kind of the app modernization approach here where we would just simply lift and shift existing container technologies into the AKS platform, do some remediation potentially on those containers and get them ready to be consumed and orchestrated by AKS. You'll hear that we have the capability of using the container registry. We can use pipelines, Azure Active Directory for security, and then we have SLA backing for services such as Azure Database for MySQL. So you'll see that this platform does play hand in hand with all of the services that we could be hosting in our Azure subscription. So getting into a customer story here, one of our customers, iSight, leverages AKS to optimize their deployment and enhance the security and reduce cost of their environment. So they needed a highly available, portable, secure, and scalable application deployment solution. And they were using a legacy container tool for this previously. The challenges were customer isolation, data migration, and organizational experience with Kubernetes. They needed to spend less time on their container management, automate and implement CI/CD, and have full visibility to the application, containers, and infrastructure. So what we did is we worked on building an architecture hand in hand with the iSight team that hosted their applications and databases inside of containers that were all communicating together in individual namespaces. You'll see at the bottom we have tenant 1 and tenant 2. The main point here is that we were able to isolate all data and communication between those two tenants while using the same cluster. And so we do have isolation of individual workloads while using the same resources. And so this is what really helps with node density and when we're trying to scale a number of customers onto a single platform. Some of the results were that they had reduced environment provisioning time, cost saving compared to their legacy container solution, 100% automated production deployments, less time spent on managing keys and certificates, and increased developer autonomy, where their developers are now empowered to go and push changes that would then get approved through the pipeline.
Yeah, so from a Microsoft, I said this earlier, but I mean, Microsoft has fully embraced the open source culture overall, and quite frankly, helped advance it overall with their acquisition of Git, a lot of their tool sets that they've implemented inside of Azure. Some examples are, a third of the VMs in Azure are Linux. That's pretty impressive overall. From a actual like proof on paper, Microsoft actually contributes. They're the number 2 individual contributors to Kubernetes, which is huge. Number 4 to Dockers, which is all very, very, very relevant to this conversation.
Mm-hmm. Yeah, great. Thank you so much. So we've got a few resources here that we'd like to share with everyone to get started with AKS and to kind of get your feet wet with understanding the orchestration of the containers and to learn a little bit more about it yourself.
Yeah. And you'll get this as we distribute out the deck at a follow-up for those of you who attend. If you're watching a recording and would like a copy of the deck, please feel free to reach out to us and to contact us on cortec.com. So how to really get started overall, again, we go back to the cloud adoption framework and just making sure that you have your organization is set up for success for Azure from a way you guys work together as a company, as well as down to the technical design and just making sure that you really have everything set up for success. A lot of great resources out there, azure.com/CAF. You can find a lot of great information, or feel free to reach out to Brett or I will show our contact info here in a second. Another way to get started would be to reach out to us directly. Go to cortec.com, contact us, and we can get started with an app innovation engagement and help you start planning how to migrate a specific workload or application to Azure. We can partner heavily with Microsoft through that process or not, depending on the direction that you want to go. But we're definitely here to help you overall. Feel free to connect with myself, Clint, or Brett via LinkedIn, and we'll be happy to respond to any questions you have. Kevin, I'll turn it over to you for questions and answers.
Yeah, we'll take a look here. I know we're a little over time here, but not too bad of shape. One of the questions we do have here is, what do you see as the biggest challenge in starting with the use of Kubernetes?
Okay. Yeah, great. So one of the first challenges that we see a lot of organizations having is that the security of and the governance of their infrastructure needs to be maintained while building out that platform. And so one of the first things we like to focus in on is, how is traffic going to come in and leave the AKS infrastructure? Before we start standing up these containers, we want to make sure that it's secured and that any ingress controllers that we may need to have in place are set there and are properly tested before that we start publishing our full containers.
Great. That looks to be the only question at the moment. So as Clint mentioned, what we'll go ahead and do is we'll send this slide deck out with the recording for everyone who attended here today. If you were not in attendance and are watching the recording and would like the slide deck, again, the easiest way to probably get that sent over to you is just to reply to the email with the recording, and we'll get that over that way. Or you can, of course, head to the website, hit the contact button at the top of the page, and we'd be happy to help you out that way too. But that looks like we'll go ahead and wrap up today's webinar. We just want to go ahead and thank both Clint and Brett for taking some time today to walk us through this. And then I want to thank everybody who was in attendance for joining us today. We will be back again for another webinar next Tuesday as we keep the Tech Tuesday webinar trainer rolling. I'll be taking a look at demystifying Microsoft licensing. And that will be with Chris Chalda. So
that'll be a good one for sure.
Yep. So if you haven't had a chance to be on a webinar previously with Chris, he does a fantastic job. He's one of our senior solution architects here, and he does a pretty great job with it. Not that Brett and Clint didn't do a great job here today, but definitely Chris is pretty good. So. Yeah, again, just want to thank everybody for tuning in today, and we'll be sending the recording out, and we'll see you during the next Tech Tuesday webinar.
All right, thank you all very much.
Thank you.